Hello, my name is Braxton. For my final project, I created a 4D chess interpreter in Rust, and also a few example programs to showcase what this project can do. First, I'll start off by explaining what 4DChess is. This is the GitHub repository that houses all the code and example programs, and this is where pretty much my whole project will live. As described on their Wikipedia page, 4DChess is an esoteric programming language designed by that user on November 18th, 2019. It is directly inspired from another esoteric programming language called BrainF, and instead of that programming language's usual one-dimensional cell array, 4DChess uses a four-dimensional hypercube-like memory cell array of 8 cells per dimension. It uses 8 cells because a chessboard has essentially 8 cells going one way, a length of 8. An esoteric language essentially means it's kind of like a convoluted way to program. Instead of using the usual grammar of C, Rust, or anything that's more widely used, it uses very few characters like a plus sign. We'll get into the grammar of that language later. I chose this programming language simply because it kind of piqued my interest, and I haven't found a 4DChess interpreter, so I decided I wanted to be the first. We'll first go look through a few commits, then I will show you some of the code behind it and explain it. I will show you the code of what a 4DChess program would look like and show you how they run. So first we'll come up to the commit list and look down here, and we're going to look at this commit first. This is kind of the starting of the programming language, or the interpreter, my bad. So if we look into this main file, this is kind of a mess. I started off on the wrong path. The way I wanted to look for the length of the arguments, and this just was kind of a blind starting. I opened a file, I parsed through each character one by one, and used this interpret function to do something. The commit 2, we go back here to implement lexer and parse opcodes. This, we will look through the main code here. And here, I discovered what enums are. They kind of allow me to more accurately describe the code that I'm doing. And I also looked through the interpreter Wikipedia page and researched more interpreters are, and I decided I wanted to go the lexer, parser, and then run route. So this is where I created the lexer. It essentially took in each symbol and matched like the character to an opcode. So the plus character means the increment opcode, or these angle brackets meaning increment or looping, and just kind of the start of a more formal interpreter. Now I want to go on to one more commit where I cleaned up the main function. We'll look through the code here at this point. Also, the directory structure is kind of changing a little bit. I added a samples folder where I wrote some sample code to interpret. So here, after we already went through all the enums and the lexer function, I created a parser function, which took in opcodes and outputted instructions. This was necessary because opcodes, it's more or less down here what the looping logic comes in. I was able to tell where a loop began and where a loop ended, but I couldn't really determine what to do with it. I couldn't implement instructions. So that's why I have to add this final line here to the instruction enum. This kind of goes through and parses each opcode and points it to the instruction. And here's again where I can start to add some loop logic. Going through all that, making sure it has the loop start and end. And I also kind of cleaned up this main function. I found an easier way to parse the amount of arguments passed to the function. And instead of parsing character by character in the main function, I parsed the file into a single string, and I let the lexer parse through each symbol instead of the main function, which is what it's supposed to do. Now the next commit, I did not name it probably the best, work in progress. But here is kind of another big jump. I created the function that essentially runs every instruction, how it should. So pass lexer, once it passes lexer with lots of opcodes, then it goes into the parser, which parses the opcodes into instructions. And then the run function parses the instructions into actual logic. Here we have to pass through instructions, and the tape, which is essentially that 8x8x8x8 hypercube, kind of the memory that I want to pass through the program. And also you'll see here how I have every pointer, the X, Y, Z, and W axis. That gets fixed up later too. So here I can see whenever I get the increment X pointer, I have to increment the X. Just go through each instruction and give their actual logic. When I want to increment at a certain pointer or a certain cell, I plus equals 1 or minus equals 1. And then I left out this logic. This is why it was a work in progress, because I didn't fully implement the run function. Later, we will write the logic for the write, read, and loop functions. Now through another commit, the 5th commit of me stepping through, this is where I start to split up this whole project into multiple files to kind of keep it more readable. So again, previously when I went into the source folder, it was just that main.rs file. However, now I split it into their individual functions, the lexer, the parser, the runner, so I know what each file does. You can see how this cleaned up the main file dramatically. Load through each module and use their certain functions, and that cleaned this up dramatically. So again, if we go through, here's the lexer, then this is only the lexer code. Go through the parser.rs, and this is only the parser code. This allows me to differentiate very easily between which functions and not just one mess in the main file. And now we're going to go back to this issue that I showcased before, where it's not in the main, it's in the runner, where I see this pointer X, pointer Y, pointer Z, and pointer W. This seems like that this could be fixed with an array. And that was, I didn't know exactly how to do that, so I had to go through the Rust documentation. And I'll show you in the main function where this is kind of, it repeats itself. So I thought maybe if I do an array and pass through only an array here, that could work. And that's what I did. If we go back here to the full commit list, there's also a bug where the tape wasn't like an actual 8x8x8x8 hypercube. I had to fix through that bug. I can show you this line. It was only the difference between a comma and a semicolon. Now, here is this commit where I'll just show the diff that shows what I had to change. So I added this new variable called pointers, and I just created an empty array full of zeros for long because there was 4 axes. And then I was able to, instead of this whole function definition, like with, I believe, 6 arguments, it was now down to 3. I halved that size, which makes it easier to write code for, as you can see here. This versus this line. And also, I added a little bit more redundant code. I had to specify that the pointer was of type usize, which is something in Rust type definition, as you can see in kind of C, sometimes in Python, but usually can interpret that correctly. However, not in Rust. They like kind of more explicit, an explicit definition. So I do clean this up. I changed the pointers array to of type usize rather than U8, which is an 8-byte unsigned integer. And eventually I clean this all up. So now we're on to the current code. This is all the code I've written. I now have a few sample programs. Now this is, I will go through a little bit of the code of each and see how, I'll show you how kind of convoluted it is. Why, kind of wondering why people would ever want to write in this. Here's a simple cat program. A cat program, it's usually used within the Linux world, is if it'll print out what you put into it. So if I type ABCD into this program, it will type out ABCD to me. Usually used in So if I could actually showcase this program, it's cat, and then I'll just show the license. Or if I cat hello world. Okay. Clearly I don't know Linux that well. So it'll just print out what is put into the program, essentially. And that's all there is to it. See, kind of weird. We like seeing words that kind of tell us what we're doing. Another example where I can output the entire ASCII char set is something as simple as that. Now, this doesn't kind of give you a big picture of what you can do with the programming language. Actually, the Hello World program is kind of the most complicated, you could say, out of all these. Whereas this is more typical to C. And now I will run it to show you how it works. So if I go into this directory, I can also show you how to build it. It's directly on the README. You clone the repository CD into it, and you need to have Rust installed. So if I do cargo build, it builds the program, or I can do cargo build release for a more optimized and production-ready program. It's found in the target release, and then HyperChess RS, that's the project name. And then it'll give me that error where I need to use, I have to put in a 4DC file. That's just the file extension that I chose for this. Now if we go under samples, and let's start with the cat program. As you can see, nothing has happened. However, if I put in ABCD, it will read back ABCD to me. And we can also put side by side that code for that program. If I cat samples and cat, that's all that code that needs to be done, and that's what makes of it. Now I can also output the entire ASCII table, or at least Rust's implementation, and samples directory ASCII char set. That shows all of that. Shows every character in basic ASCII. Very simple there. And now for the infamous hello world. Again, I will show the code alongside it. Cat samples hello world. That is the code that's used to run it. And if we run it, target release HyperChess RS, and it's in the samples and hello world. There's hello world printed out to the screen. Now I list kind of what I want to add to this feature, like where can I take it from here, because this was actually a very fun project for me to build. I want to optimize it. I believe there is more faster implementations. I can take that from that parent language that I'm not allowed to say and translate that into this interpreter. For example, loops, they can be done much faster, and I want to do some timings and actually use Rust's unit tests to see how well I cover that. I want to add more sample programs. For example, I can list out all the Fibonacci, or up into a certain point, the Fibonacci sequence. I just need to take advantage of that 8x8x8x8 hypercube of memory. I want to clean up the runner file. If we go here, this seems like a lot. I want to see what I can do here to minify it, essentially, while it's still being readable. And one last thing, I'm going to add it to the Esolings kind of Wikipedia page. This is their Wikipedia page where it kind of explains this whole this was my guideline to create the programming language, or the interpreter. And I want to add it so other people can write their own 4DChess programs, because, again, I have not seen an interpreter, and I have not seen programs written for it. So that's kind of what inclined me to be the first. Thank you for watching. I assume you'll be able to run it as long as you know how to install Rust. And none of this was really Linux specific as I anticipated it to be, but there's no Linux specific code in here, and Rust is really good about cross-compiling like that. And that is my project. Thank you for watching.